Okay, let's finish these last three integrals. 11f is going to turn into an arc sine. Whenever you have 1 over a square root, and inside the square root you have a quadratic, if the x squared term has a negative coefficient, then you might suspect that it's going to turn into an arc sine once we complete the square. So let's start by completing the square of that quadratic that's underneath the radical. All right, factor out the negative. Now we're going to add and subtract half of 10 squared, so that's 25. Add and subtract. Just a second here. Let me subtract that. Okay. All right, add and subtract. 25. All right, and then we have that minus 24. Sorry, we factored out the negative, so now it's a plus 24. Okay, now the first three terms are a perfect square. That is, this is a perfect square. Factor that perfect square as x plus 5 squared. And this is minus 1. Now let's open up the parentheses, multiplying through by that minus, and we have 1 minus x plus 5 squared. So now the integral is going to look a little bit more like an arc sine. Let's rewrite. Okay, so there we go. And that's an arc sine. So using the formula for an arc sine integral, this is equal to arc sine. U is x plus 5. And a is 1. All right, let's look at G. I'm going to rewrite G in such a way that hopefully you'll recognize that this is an arctan integral. Okay, just by rewriting x to the fourth as x squared squared. So now if we put u equal to x squared, then du is 2x dx, and we have x dx over here. All right, so we have u equal x squared. Du is 2x dx. So x dx is 1/2 du. So this is 1/2. X dx is 1/2 du. And here we have u squared plus 1. All right, so that's equal to, let's keep that 1/2 in front. And then we have 1 over a, but a is 1 here, so that's just arctan. U over a, that's u over 1. And u is x squared. All right. And finally, let's do h. Okay, here I'll rewrite this a little bit. I'll write this as arctan x and times 1 over 1 plus x squared dx. So we recognize that the derivative of arctan x is right here. 1 over 1 plus x squared. So we'll put u equal to arctan, and all this is du. So this integral is simply u du. Simple power rule, u squared over 2. And then substitute back u equal to arctan x. And that's it. That's the end of the review.